Hello guys, I welcome you all in this course Dynamics in the Department of Mechanical Engineering, Faculty of Engineering. Today we will discuss the topic is the kinematics of particles, Newton's second law. Let's move on. Okay, the content what we are going to cover in this lecture, the content is this one. We will do the introduction, Newton's second law of motion, linear momentum of particles, system of unit, equation of motion, and dynamics equilibrium. And the rest we have the sample problem 12.1, 3, 4, 5 and 6. And the second is what we will cover in this video, angular momentum of a particles, equation of motion in radial and transverse components, conservation of angular momentum, Newton's law of gravitation. Then we are going to solve it, problem 12.7 and 8. Okay, let's let's do the introduction part. Newton's first law and third law are sufficient for the study of bodies at rest, means statics, or body in motion with no acceleration. When a body accelerates, change in velocity, magnitude or direction, Newton's second law is required to relate the motion of the body to the force acting on it. And the next is now the Newton's second law. What is Newton's second law? A particle will have an acceleration proportional to the magnitude of the resultant force acting on it and in the direction of the resultant force. Now is this second point. The resultant of the force acting on the particle is equal to the rate of change of linear momentum of the particles. Third point of the Newton's second law of motion, the sum of the momentum about O of the force acting on a particle is equal to the rate of change of angular momentum of the particle about O. Slide move on. Okay, here we will try to understand Newton's second law of motion, which is you have already studied in physics part. In this video, just we will try to cover it overview of the Newton's second law of motion. Okay, now is Newton's second law of motion. If the resultant force acting on a particle is not zero, the particle will have an acceleration proportional to the magnitude of resultant and in the direction of the resultant. Okay, in the coming point, consider a particle subject to the constant force. Force is in this direction, the acceleration, and if is the same direction, and if mass always constant, F1 over acceleration 1 is equal to 1, 2 and 3. The same constant, this one is the mass. When a particle of mass m is acting upon a force F, the acceleration of the particle must satisfy F is equal to ma. Acceleration must be evaluated with respect to Newtonian frame of the reference, for instance, one that is not accelerating or rotating. If force acting on particle is zero, particle will not have accelerate. For instance, it will remain stationary or continue on a straight line at constant velocity. You can see in the given figures F is equal to ma. Okay, so let's move on. Now we will try to cover the linear momentum of a particles. You can see in the curve, that is the curve mv, that is the mass and the velocity. Replacing the acceleration by the derive of the velocity yield. Summation of F is equal to m dv over dt. When we derive it, we got this equation. Okay, now is the question is here, what is L? L is linear momentum of particle. What is the linear momentum conservation principle? Now we will talk the principle. If the resultant force on a particle is zero, the linear momentum of the particle remain constant on both magnitude and the direction. You can see here. Okay, here in this slide, in the here is a system of unit. We will use SI unit. SI unit mean international system of unit. On the vice versa, we can use US unit, customary unit. Okay, let me define of the unit four primary dimensions. Four primary dimensions. One, force, the second is mass, third is length, and the last one is the time. Three may be chosen arbitrarily. The fourth must be compatible with Newton's second law. Look, the force is the equal to 1 Newton is going to in this direction. What is the mass? 1 kg, and the acceleration is equal to 1 meter per second square. Okay, international system of unit. Basis units are the unit of length. Unit of length is m, and the mass is kilogram, and the time unit is second. The unit of the force is derived. The remaining the force unit, 1 Newton is equal to 1 kg, 1 kilogram into 1 meter per second square, equal to 1 kilogram into meter over second square. That is the international system of units. Okay, the next is customary unit. Base unit are the units of force. This one is the pound, lb, and the length in meter unit, and the time is the second unit. For the time is second unit. The unit of mass is derived. The 1 pound is equal to that one, 1 pound meter is equal to 1 pound over 32.2 feet over second square. That is the US unit. As you can see here, if is it the mass in downside, that time is weight is equal to 9.81 Newton is the G value, and the acceleration is as well 9.81 meter per second square. If is it the in pound, that time is changing the units, that's it. If is it in direction in this side as well, the value this one is in pound, only that is the changed. You can see the only the unit that is the international unit, the other one is the US unit. Equation of motion. Okay, here I will try to just overview equation of motion. Newton's second law provides summation of F is equal to ma. Okay, solution for particle motion is facilitated by the resolving vector equation into scalar component equation. For example, result rectangular component. Summation of ffx I plus ffy j plus ffz k is equal to m axi plus ayj plus azk. That is the equation we got it from here. Okay, we simplify these equations and then we are going to cover the next point for the tangential and the normal component. For the tangential, for the normal component, the equation is here and the figure is written in this side. Now is the second is the dynamic equilibrium. Dynamic equilibrium, alternate expression of unit second law. ff summation of f before was ff summation of f is equal to ma. Now we just change the alternate expression of unit second law of motion. We bring from equal to 0. Summation of ff minus ma, and minus ma, that is the internal vector. With the inclusion of the inertial vector, the system of force acting on the particle is equal to the 0. The particle is in dynamic equilibrium. The method developed for particle in static equilibrium may be applied. For example, complanar force may be represented with a closed vector polygon. Inertia vectors are often called internal force as they measure resistance the particles offer to change in motion, for instance, change in speed or direction. Internal force may be conceptually useful but are not like the contact and gravitational force found in statics. Here is a problem. Sample problem is 21. The problem is here a 200-pound block. That block at is rest on horizontal plane. Find the magnitude of the force. This one magnitude of the force P required to give the block an acceleration or 10 feet per second square to the right. The coefficient of the kinematic friction between the block and the plane is 0.25. Okay, the coefficient of the friction between that block and the plane, what is the coefficient friction is 0.25. Okay, the solution, the sum point is written here, please. Resolve the equation of motion for the block into two rectangular component equation. Unknown consist of the applied force P and the normal action N from the plane. The two equations may be solved by these unknowns. Okay, here is a free body diagram. You can see is the Newton. The Newton force is in this direction. This force is in this side. The weight is 200 pound, and the P is, he said, we need to calculate. Okay, the angle is 30 degree. Okay, the summation of fx in x direction, f of x is equal to ma p cos 30 degree minus 0.25 Newton. That is the coefficient of friction. When we simplify derive, that is the we get the calculate. Okay, when okay, one point what I want to ask you, 6.21 pound into seconds square over feet. Where we got this one? We have calculated here. Mass is equal to W over G. W weight, what is given? This one. And the what is the G value? G value in, if is it international, 9.81. Here we use in pound in British. So we use 32.2 feet over second square. That is the calculation value. Okay. How we can calculate the friction force is coefficient of friction. Okay, in y direction, n is into minus p sine 30 minus 200 pound is equal to 0. Okay, here I will give the some hints. Unknown consists of the applied force P and the normal reaction N from the plane. The two equations may be solved for these unknowns. N is equal to just uh, these values I transfer to this side. So N is equal to P sine 30 plus 200 pound. What we need to calculate? The P magnitude. Okay, the value is it given? Put the value, you got the answer. Okay, let's move to the second one. This question is nice. Okay, why this one is not going behind? No. Okay, it's gone. I don't know why the system is not sending to me back, but okay, you can solve it that question. Okay, let's try to solve that. This question is as well important. And the sample problem. The 12 pound block B, this one is the 12 pound block B, start from rest and the slide on 30 wedge A. Okay, which is this supported by the horizontal surface. Neglecting friction, determine the acceleration of the edge, and the B, the acceleration of the block relative to the edge. Okay, the solution is here. The block is concentrate to slide down the wedge, therefore their motion are dependent. Express the acceleration of block as the acceleration of edge plus the acceleration of the block relative to the edge. Write the equation of motion for the edge and block. Solve for the acceleration. Okay, this equation is very nice, is important, may come into your exam. Maybe the same, maybe from the homework. I hope you will see this question. Similar but not the same value. The solution is here. The block is concentrated into slide down the edge. Therefore, their motion are dependent. That is the equation A B is equal to acceleration A plus B over A. Write the equation of motion for edge and block. We wrote it in x direction, in y direction. That is the as well. Yes, that is the complete x direction. Okay, that is the y direction. The free body diagram that is given. Please try to understand. Let's move on. Okay, here solve the acceleration. Okay, the value is here given in the previous slides. Put this value in these equations. So you solve the acceleration here, 5.07 feet per second square, and that is the equation. The value what you got it, you put here this value because we need it, that one, so you can get this value. Okay, let's move on. Okay, this I want you to solve this question. May it help you to understand. I hope you study this question as well in physics. That is the basics. You can see this slides, this presentation file, this PPT file. You can find in the description or on the Zoom account in nearest. Let's move on. The solution is here. You can see it. Okay, that sample problem is very nice. You can see it. Please try to solve it as well, this one. Okay, here we will try to cover it. Angular momentum of a particle, second part of the topics. Now here we are going to discuss. Here HO, that one, is equal to radius into mv, moment of momentum or the angular momentum of the particle about O. HO is perpendicular, that is the perpendicular to the plane containing R. Okay, and mv. Okay, HO is equal to R mv sine theta. When you derive, you got it, this one is simplification, and as well is you can see there, this one is HO as well, you can find from there. Okay, derivative of angular momentum with respect to time, simplified, you can simplify it, you will get it, this one can see in this graph is explaining in very well way. It follow from Newton's second law, the sum of the moments about O of the force, that one, okay, acting on the particle is equal to the rate of change of angular momentum of the particle about O. Okay, consider particle at r or theta in polar coordinate. The polar coordinate is here. The very simple equations, I consider you know that. I have to suppose. Okay, now here is conservation of angular momentum. When only force acting on a particle is directed toward or away from fixed point O, that point, The particle is said to be moving under a central force. Since the line of action of central force passes through the O is equal to summation of MO is equal to HO is equal to 0 and the simplified equation is equal to constant. The position vector and motion of particle are in a plane perpendicular to HO, magnitude of angular momentum. Okay, HO is equal to RMV sine theta is equal to constant. Simplification equation is here. You can see from the figure as well. Let's move on. Here, what I want to tell you, Newton's law of gravitational. There is a gravitational force exerted by the sun on a planet or by the earth on a satellite is an important example of the gravitational force. Newton's law of universal gravitation. Two particles of mass m, this one, okay, and the mass n, this one, attract each other with equal, they are attract each other equal but the opposite force direction along with the line containing the particle. You can see is it here. F is equal to g m over radius square. What is g? G is the constant of gravitational and that is the value of g in international unit and the other US unit. For particle of mass m on the earth's surface, W is equal to mg over r square is equal to mg. Okay, what is the value of g in SI unit? In SI unit is 9.81 meter over second square. If is it British unit, you can write it in this form. British unit is 32.2 feet over second square. Here the example is sample example is given. A block B, this one block B of mass m can slide freely on a frictionless arm OA from this side to this side, which rotate on a horizontal plane at a constant rate is theta 0. What we know that in this question, knowing that the B is released at distance or not, okay, from O, express and friction of R. What we need to calculate is the part A, the component VR of the velocity of B along OA, and the point B is the magnitude of the horizontal force exerted on B by the arm on A. Okay, here I wrote it some hints in this solution. Write the radical and transitive equation of motion for the block. The first point, integrate the radical equation to find an expression for the radical velocity. Substitute known information into the transitive equation to find an expression for the force on the block. I gave you the hint in the previous slide. I want you to solve it by your hand. Try to understand. If you have Please you can ask question in the description box. And the last one of this sample problem is this one is attached. You can find it this PPT file, presentation file, in the description file, or in university account is they called is Zoom account. You can find from there. Please try to solve it by yourself. The solution is here. I hope you understand. If you have any question, please you can ask anytime in the description, or you can ask by the email. Okay, thank you so much. Hopefully you understand. Bye bye.